Hello and welcome back to the next part of our Chapter 4 series here, where we're learning about standard deviation. So as you can see, we left off here talking about the standard deviation formula, which, if we go back real quick, remember when we're talking about standard deviation, we're first trying to learn information of points around the mean. So in order to find out the average around the mean, or points around the mean, the spread around the mean, however you want to phrase this, we have to find out the deviations. And if we take the deviations, which is x sub I minus x bar, that'll give you a deviation. But if you were to add up all the deviations, your sum is going to equal to 0, because the deviations is what makes up the average. And so from that, we need to be able to take these numbers and turn them into a value that we can actually use. So in order to do this, what we're going to do is we're going to square them. By squaring them, we're going to give all the negative deviations a positive value here. And then once we give all these deviations a positive value, we can add them up. And when we add them up, this is what's called the sum of squares, or SS. And then we can take the SS and divide it by n minus 1, the degrees of freedom, which will then give us the sample variance of s squared. And then we take s squared, take the square root of that to get s, which is our sample standard deviation. So our total formula looks something more like this, where we have the standard deviation of s is equal to the square root of 1 over n times the sum of x sub I minus x bar squared. Now, just point this out here, this part of the formula is the sum of squares, and then it can either be written where you multiply by 1 over the n minus 1 or divide by n minus 1. It's the same thing, and then we want to make sure to take the square root to go from our sample variance to our standard deviation. The reason we take the square root is we're taking the square value that we use to get a positive value, and we're going back into the actual units that were first there. That's why we take the square root. Another thing to notice is that the sample standard deviation is notated as S, so you'll notice as S, that's a sample standard deviation, and is the estimated of population standard deviation of sigma. So here's sigma, so when you see this value here, this is lowercase sigma, whereas our sigma sign here, that looks like a big capital E, that's capital sigma. When you see a capital sigma, it means to sum. When you see a lowercase sigma, this little guy here, that means standard deviation of a population. You can read more about this on page 93, as well as going online and just typing in standard deviation. You will get a world of information. All right, so here we have an example from the book, which I think walks you through step by step of exactly how to calculate standard deviation. So over here on the left-hand side, we have our observations, right? So here's our x sub I, so these are our data points, right? And then if you add these all up, divide by the total number there is, you're going to get your x bar. And x bar here, as we notated earlier, is 36. Now if you were to take all the data points minus x bar, so x sub I minus x bar, you're going to get your deviations. And so these are all the deviation values. Now if you add them all up, you'll notice that the sum is equal to 0. And that's because the average is the average point from the largest and smallest distance to each other, and so they're going to be adding up to 0. In order to actually get valuable information out of it, we need to get these negative numbers and get them to a positive value, which is now why we square it. And then when you square the deviations, so you would take 0 squared, 2 squared, 3 squared, 4 squared, right, shown over here, and we're going to get the sum of squares. So we're going to get these values, and we're going to add them all up, and you're going to get the sum of squared, which then this value is 58. Then we're going to take our sum of squares, which is 58, and put it into our formula, and we're going to take that over n minus 1, so n here is 8, and then minus 1 would be 7, so it would be 58 divided by 7, which is equal to 8.2857. Now once again, at the end of this video, maybe in the next one, depending on how much time there is, we'll be talking about the decimal lengths and stuff. Once again, you're going to see a lot of examples where I go at least 4 decimals deep. Biggest thing to do is when we're talking about decimals and rounding is you don't round until you have the final answer, which I'll talk about, and we want to just go one more decimal past the largest decimal given. So I will explain what that looks like going forward. and the reason behind that. But so for right now, if you see videos where they're 4 decimals long or less, it's going to be okay. I check everything. As long as your work always matches up to what your answer is, you'll be in good shape. Back to our standard deviation though. So we get it and we have our variance. Our S squared is 8.2857. And then if we want to take our variance and go to standard deviation, we take the square root of our variance. So we go, S is going to equal to the square root of S squared. So the square root of 8.2857, which will be 2.8785. And that would be our standard deviation. So our interpretation of standard deviation, once again, it measures the spread around the mean. So if a group had a standard deviation of 15 and group 2 had a standard deviation of 10, group 1 has more spread, right? There's a greater spread around the mean. What else does this tell us? Well, there's two key things that the standard deviation will tell us, or two main areas that we can look at. And we're going to be looking at the 68, 95, 99.7 rule in the next section, and then also we're going to be talking about Chebyshev's rule. For the purposes of our class, we're going to be mostly focusing on the 68, 95, 99.7 rule. Chebyshev's rule is good to know and understand, but for the purposes of our class and how everything is going to be going forward, we're going to be mostly focusing on the 68, 95, 99.7 rule. And so what is the 68, 95, 99.7 rule? Well, this rule only works for normal distributions, okay? If the distribution is not normal or it's not symmetrical, then this rule does not apply. And what the rule states is that 68% of the data will be in the range of mu plus or minus sigma, or mu plus or minus the standard deviation. And that 95% of the data will be in range of mu plus or minus 2 standard deviations, and 99.7% of the data will be in the range of mu plus or minus 3 standard deviations. For right now, this is all we need to know, is that 68% of the data will be within plus or minus 1 standard deviation, 95% will be in plus or minus 2, and 99.7% will be plus or minus 3 standard deviations from the mean. That is what the 68, 95, 99.7 rule. We will get more into that as we start getting into, I believe, chapter 7. For right now, this is what we're something to definitely know and take note of. So here's an example. So suppose the variable has a normal distribution with 30 and a standard deviation of 10. Then we would say 68% of the values fall between 20 and 40, right? So we take 30 plus or minus 10, that would give us the 20 to 40. And then 95% of the values will be between 30 plus or minus 2 standard deviations of 10, right? So it'd be 30 plus or minus 20, which is 10 to 50. And 99.7 are between 30 plus or minus 3 standard deviations from the mean, so 30 plus or minus 30 would be 0 to 60. Chebyshev's rule for all distributions states that at least 75% of the values will fall in the range of the mean plus or minus 2 standard deviations for any shape of distribution. So remember, when we're talking about a 68, 95, 99.7, this is only for normal distributions. However, if you have a different type of distribution, we can then follow Chebyshev's rule, which will say at least 75% of the values will fall in the range of plus or minus 2 standard deviations for any shape of the distribution. So here's an example. So you have a distribution of a mean 30 and a standard deviation 10, has at least 75% of the values in range of 30 plus or minus 2 standard deviations of 10. So that would be 10 to 50, 75% of the value falls there. So here we have an example. Hopefully I can get through this relatively quickly. If not, I might stop and do another video for the very last part. But let's go into it. Feel free to pause the video. We're going to basically be doing an example of birth weights here. So we have our sample set of birth weights shown here, and we want to find the mean, median, and standard deviation of it. So, let me go back. Here we go. So when we want to do this, we want to find the mean, median, standard deviation. So first thing we need to do, as always, a great practice to get into, is how many data points do we have here? So we have 1, 2, 3, 4, 5, 6, 7. So we have n equals 7. Great thing to do. All right, so we can find the mean really quickly by adding all these values up and divide by a total number of 7. Median is going to be the middle value, and then standard deviation is going to be a little bit longer. And we're going to need the mean in order to find standard deviation. So the best thing to do is probably just solve for the median first. Let's look at our data set in order. So in order to do the median, we need to have an order array, and these values are not in order. So we need to put these values in order. So we're going to do 6.1, 6.3, 6.5, 6.8, and make that 7, 7.4, and 7.6. So we know that if we want to find the median, we can find the depth first, right? And the depth is going to be n plus 1 over 2. Our n is 7 plus 1 over 2 is going to be 8 over 2, which is going to be equal to 4. So our median is going to be 4 units in. So 1, 2, 3, 4. Right? Here's our median. It's the middle value, divides the set into upper and lower half here. So our median value is going to be equal to 6.8. Now we need to find the mean. So the mean would be adding up all the values and dividing by the total number. If you add all these up for the purposes of time, you're going to get a value of 47.7 divided by 7, which is going to give us a mean of 6.81. Or you can write this as x bar is equal to 6.81. Now we need to set up our standard deviation. So if you remember, our standard deviation formula is going to be x sub I minus our x bar. We're going to square those values and sum them, right? And this is going to give us our sum of squares. We're going to take our sum of squares, divide by n minus 1, our degrees of freedom, and then get back into our original units. We're going to take the square root, and this is equal to our standard deviation. So the best way I always tackle this problem is I would rewrite the values and almost follow exactly how that chart in our book did it, because it's a very simple step-by-step process. So here are our values, and we're going to subtract these from our x bar, our mean, all the way down. And now we have set up our deviations. Now if we were to do this and equal these and then sum them, our value is going to be equal to 0. Well, that's not going to tell us anything, so we have to get to the sum of squares. So our x minus x bar squared. So I'm going to do this a little quick here. Oops. Oh, now I need the settings. Here we go. Eraser. Messed up a little bit. All right, back here. And hopefully I can do this a little quickly because we're running close on time. So here we have our deviations minus our x sub I minus x bar. And if we do this, we're going to get -71. Pro tip, if we know you're going to square it and you're using a calculator, just square it right away. That way you're not wasting time solving one particular, like, don't just get all the deviations then go back and resquare. You already have this value in the calculator. A lot of times you can just square these values right away. And when you do that, it'll save you a little bit of time on homework, exam, going forward. So that's what I'm kind of doing here. I'm just getting through these. And you'll notice right now that I'm only going 2 decimals deep. And that is because we're going to report our value 1 decimal larger than the decimals that are given for the significant figures. And so we only went 1 decimal to the tens place, so we're going to go into the hundreds place in our answer, so I'm only going 2 out right now. So once you have your deviations and you square them, then you can add up our square deviations to get our sum of squares, which is going to be 1.84. And then we're going to take 1.84 divided by n minus 1. So our n, once again, if we just look up, we don't have to recount. Great thing. It's going to be 7 minus 1, which is going to be 6. So it's 1.84 divided by 6, which is going to give you a value of 0.30. Remember not to round until the very end of the problem. You have 0.30. And this is going to equal our variance. And we want to go from our variance to standard deviation, remember we take the square root, so we're going to be taking S is going to equal the square root of 0.30, so S is going to equal 0.55 here, and so we would say our standard deviation is 0.55 units of the weight in pounds. And that is how we do standard deviation. I will pick this back up in the next video and talk a little bit more and finish this chapter out. See you in the next video.